Hello champs, and welcome back to School Revise. Before we begin today's chapter, I want you to look at something. Just watch. A cricket ball hit hard, flying through the air. A football struck cleanly, curving towards the goal. A fireworks rocket rising into the night sky. A space rocket lifting off from the launchpad and curving as it climbs. A dolphin leaping out of the ocean. And a roller coaster sweeping over the top of a hill. 6 completely different examples, right? A sport, a game, a celebration. A rocket, an animal, and a theme park ride. But here is what I want you to notice. The shape they make. The path each one traces. It is the same shape. This curve has a name. Mathematicians call it a parabola. And every single parabola you have ever seen in your entire life can be described by one single equation. That is, y equals ax squared plus bx plus c. This equation is called a polynomial. And that is what we are learning today. Chapter 2, Polynomials. By the end of this video you will understand 4 things. 1. What a polynomial actually is. The definition, the types, how to spot one and how to spot something that is not a polynomial. 2. What the zeros of a polynomial are, and why they are the single most important idea in this chapter. 3. The beautiful relationship between the zeros of a polynomial and its coefficients. This is the part that feels like magic when you first see it. 4. The division algorithm for polynomials, which sounds complicated but is actually just long division, the same long division you have been doing since grade 4. Just with excess instead of numbers. So take a deep breath, open your notebook, and let us begin with the most important question of all, what is a polynomial? So, what is a polynomial? Let us not start with a definition. Let us start with some examples. Look at these 3 expressions. 3x squared plus 5. 7x minus 2. 2x cubed minus 3x squared plus x minus 5. All 3 of these are polynomials. They look different. One has only an x squared. One has only an x, one has x cubed, and x squared, and x, and a number. But they share 3 things. And those 3 things are the definition of a polynomial. 1. The expression contains only the variable and numbers. Nothing else. No square roots over the variable. No signs. No logarithms. 2. The powers of x are always whole numbers. 1, 2, 3, and so on. Never 1/2. Never -1. Never any fraction or negative. 3. We never divide by the variable. The variable x sits in the numerator only, never in the denominator. Now let us look at the opposite. Here are 3 expressions that are not polynomials. 1 over x plus 3. This one fails because of rule 3. We are dividing by x. Square root of x plus 4. This one fails because of rule 2. The square root of x is the same as x to the power 1/2. And 1/2 is not a whole number. X squared plus sine of x. This one fails because of rule 1. Sine is a different kind of function. It is not just variables and numbers. Now that you know what a polynomial is, let us look at the different types. Polynomials are classified by their degree. And the degree is just the highest power of x in the expression. A polynomial with degree 0 is called a constant polynomial. The number 7, all by itself, is a constant polynomial. The highest power of x is 0, because there is no x at all. A polynomial with degree 1 is called linear. 4x minus 9 is linear. The highest power of x is 1. A polynomial with degree 2 is called quadratic. This is the most important type for our chapter. 3x squared minus 5x plus 2 is quadratic. The highest power of x is 2. And a polynomial with degree 3 is called cubic. X cubed minus x is cubic. The highest power of x is 3. There are higher degrees too. 4, 5, 10, 100. But for class 10, the star of the show is the quadratic. The degree to polynomial. The parabola. Before we move on, one quick skill we will use a lot. When you see something like find p of 0, it means take the polynomial p of x and replace every x with 0. Then compute the result. Let us try it with this polynomial. P of x equals to x cubed minus 3x squared plus x minus 5. P of 0. Replace x with 0 everywhere. 2 times 0 cubed is 0. 3 times 0 squared is 0. Plus 0. Minus 5. Answer is minus 5. P of 1. Replace x with 1. 2 times 1 cubed is 2. Minus 3 times 1 squared is minus 3. Plus 1. Minus 5. 2, minus 3, plus 1, minus 5 is minus 5. P of minus 1. Replace x with minus 1. Be careful here. Minus 1 cubed is minus 1, so 2 times that is minus 2. Minus 1 squared is plus 1, so minus 3 times 1 is minus 3. Plus minus 1 is minus 1. Minus 5. Minus 2, minus 3, minus 1, minus 5, that is minus 11. So now you know what a polynomial is. You know the 3 rules. You know the 4 types. And you know how to find the value of a polynomial at any x. But here is the question that will unlock the whole chapter. Where does a polynomial live? On the graph, where does it go? And the most important question of all, at which x values does the polynomial become 0? That is what we explore next. So, where does a polynomial become 0? This is the most important question in this entire chapter. And the answer is beautiful. Let us begin with the definition. A0 of a polynomial is simply a value of x that makes the polynomial equal to 0. That is it. That is the whole definition. Find the values of x where the polynomial becomes 0. Those values are called the zeros of the polynomial. Let us start with the simplest case. A linear polynomial. Consider p of x equals 3x minus 12. To find the 0, we ask, what value of x makes this equal to 0? Set the polynomial equal to 0. 3x minus 12 equals 0. Add 12 to both sides. 3x equals 12. Divide both sides by 3. X equals 4. So the 0 of the polynomial 3x minus 12 is x equals 4. That is the only value of x that makes this polynomial become 0. But here is where it gets interesting. Let us look at this graphically. If we draw the graph of y equals 3x minus 12, we get a straight line. And look at what happens at x equals 4. The line crosses the x-axis exactly at x equals 4. This is the geometric meaning of a 0. A0 is the value of x where the graph of the polynomial meets the x-axis. Every linear polynomial has exactly one 0. One crossing point. One value where the line meets the x-axis. Now let us go 1 degree higher. A quadratic polynomial. Consider p of x equals x squared minus 5x plus 6. To find the zeros, we again set the polynomial equal to 0. X squared minus 5x plus 6 equals 0. We factor this by finding two numbers whose product is 6 and whose sum is 5. 2 and 3. So we can write this as x minus 2 times x minus 3 equals 0. Now the rule of zero product. If two things multiplied together give 0, then at least one of them must be 0. So either x minus 2 is 0, which gives x equals 2. Or x minus 3 is 0, which gives x equals 3. This polynomial has two zeros. X equals 2 and x equals 3. Now look at the graph. the graph of x squared minus 5x plus 6 is a parabola. And the parabola crosses the x-axis at exactly 2 points. At x equals 2. And at x equals 3. The same two values we found algebraically. This is the geometric meaning of zeros for a quadratic polynomial. The zeros are the points where the parabola crosses the x-axis. Now here is the really beautiful idea. A parabola can interact with the x-axis in 3 different ways. And these 3 ways give us the 3 possible cases for the zeros of a quadratic. Case 1. The parabola crosses the x-axis at 2 distinct points. The polynomial has 2 distinct real zeros. We just saw this example. Case 2. The parabola touches the x-axis at exactly 1 point but does not cross it. The polynomial has 1 repeated zero. An example is x minus 2 whole squared. This expands to x squared minus 4x plus 4. Its only zero is x equals 2, and it is called a repeated zero because the factor x minus 2 appears twice. Case 3. The parabola does not touch the x-axis at all. It floats above or below the x-axis. The polynomial has no real zeros. An example is x squared plus 1. Because x squared is always 0 or positive and we are adding 1, the result is always greater than 0. The graph never reaches the x-axis. So a quadratic polynomial has either 2 zeros, 1 repeated zero, or no real zeros. Never more than 2. And this leads us to one of the most important rules in this chapter. A polynomial of degree n has at most n zeros. A linear polynomial, degree 1, has at most 1 zero. A quadratic polynomial, degree 2, has at most 2 zeros. A cubic polynomial, degree 3, has at most 3 zeros. And so on. So let us take a quick pause and review. A0 is the value of x where the polynomial becomes 0. Geometrically, a 0 is where the graph touches or crosses the x-axis. A linear polynomial has exactly 1 zero. A quadratic polynomial can have 0, 1, or 2 real zeros. And in general, a polynomial of degree n has at most n zeros. Before we move forward, take a moment. Pause this video. Open your browser and head to schoolrevise.com. Find the Class 10 Maths section, open Polynomials, and try the 5 questions on finding zeros. The practice is what makes this stick. The website link is in the description. I will wait. Come back when you are done. Welcome back. Hope you practiced at schoolrevise.com. Now that you understand what zeros are, the next question is even more beautiful. There is a hidden relationship between the zeros of a polynomial and its coefficients. You can find the sum and product of the zeros without even solving the polynomial. And that is what we explore next. So, there is a hidden relationship between the zeros of a polynomial and its coefficients. Imagine you have a quadratic polynomial. And someone asks you, what is the sum of the zeros? What is the product of the zeros? Most students would say, easy. First I will solve the polynomial. Find the 2 zeros. Then add them, and multiply them. But there is a faster way. A much faster way. You can find the sum and the product of the zeros without solving the polynomial at all. This is one of the most beautiful results in Class 10 Mathematics. And it is called the relationship between zeros and coefficients. Let us begin with the general form. A quadratic polynomial is written as ax squared plus bx plus c. Here, a is the coefficient of x squared. B is the coefficient of x. And c is the constant term. Now here is the magic. If alpha and beta are the 2 zeros of this polynomial, then the sum of the zeros, alpha plus beta, equals minus b over a. And the product of the zeros, alpha times beta, equals c over a. That is it. 2 formulas. Memorize the shape of them. Sum equals minus b over a, product equals c over a. One important detail. There is a minus sign in the sum formula. Alpha plus beta is minus b over a, not plus b over a. Students lose marks on this all the time. So remember the minus. Let us verify this with a real example. Consider p of x equals to x squared minus 7x plus 3. Here we can identify a is 2, b is minus 7, c is 3. Using the formulas, the predicted sum of the zeros is minus b over a, that is minus of minus 7 over 2, which equals 7 over 2, or 3.5. The predicted product is c over a, that is 3 over 2, or 1.5. Now let us check by actually finding the zeros and computing the sum and product directly. To find the zeros, we factor by splitting the middle term. 2x squared minus 7x plus 3 equals 0. We split minus 7x as minus 6x minus 1x group and factor 2x of x minus 3 minus 1 of x minus 3 equals 0. Common factor 2x minus 1 times x minus 3 equals 0. By the zero product rule, 2x minus 1 equals 0, giving x equals 1/2. Or x minus 3 equals 0, giving x equals 3. So our zeros are 1/2 and 3. Let us check the sum. 1/2 plus 3 equals 7 over 2. That matches our prediction. Let us check the product. 1/2 times 3 equals 3 over 2. That also matches. The formulas worked. We could have known both answers without ever solving the polynomial, just by looking at the coefficients. Now here is something even more powerful. We can go in the reverse direction. If someone gives you the zeros and asks you to write the polynomial, you can do it instantly. For example, suppose someone tells you the zeros of a polynomial are 4 and minus 3. Find a polynomial that has these zeros. The recipe is simple. If the zeros are alpha and beta, the polynomial is x minus alpha times x minus beta. So with zeros 4 and minus 3, the polynomial is x minus 4 times x minus minus 3, which simplifies to x minus 4 times x plus 3. Expanding, x squared plus 3x minus 4x minus 12, which equals x squared minus x minus 12. And there is our polynomial. P of x equals x squared minus x minus 12. Built directly from the given zeros. What about cubic polynomials? Polynomials of degree 3? The same idea extends, with one extra term. Consider P of x equals x cubed minus 4x. To find the zeros, we factor. First, take x as a common factor. X cubed minus 4x equals x times x squared minus 4. And x squared minus 4 is a difference of squares, which factors as x minus 2 times x plus 2. So we have three factors, x, x minus 2, and x plus 2. Setting each equal to 0 gives three zeros, x equals 0, x equals 2, and x equals minus 2. A cubic polynomial has three zeros. Just like the rule we learned earlier. Degree 3, at most 3 zeros. Before we move to the final part of the chapter, take a moment. Pause this video. Head to schoolrevise.com. Go to the Class 10 Maths section, open Polynomials, and try the next 5 practice questions on sum and product of zeros. Come back when you are done. Welcome back. You have come a long way. You now understand what a polynomial is. You know how to find zeros. You know the geometric meaning of zeros on a graph. And you know the beautiful relationship between zeros and coefficients. There is just one final piece of the chapter left. A short recap, a glimpse at what is coming next, and we are done. This is the final part of the chapter. Let us bring everything together. 5 ideas. The whole chapter on one slide. 1. A polynomial is an expression made of only variables and numbers, where the powers of x are whole numbers. No fractional powers, no negative powers, no functions like sine or square root over x. 2. Polynomials are classified by their highest power, called the degree. Degree 0 is constant. Degree 1 is linear. Degree 2 is quadratic, the star of this chapter. Degree 3 is cubic. And so on. 3. A0 of a polynomial is a value of x that makes the polynomial equal to 0. Geometrically, it is where the graph touches or crosses the x-axis. 4. A quadratic polynomial can have 0, 1, or 2 real zeros. 3 cases, depending on whether the parabola misses, touches, or crosses the x-axis. And in general, a polynomial of degree n has at most n zeros. 5. The hidden relationship. For any quadratic ax squared plus bx plus c, the sum of the zeros is minus b over a, and the product is c over a. Memorize these. They will save you time on every exam. A quick glimpse at what is ahead. In class 11 and beyond, you will explore cubic polynomials in detail. Their graph is an S-shape, crossing the x-axis up to 3 times. You will meet quadratic polynomials, degree 4. Their graph looks like a W or an upside-down W, crossing the x-axis up to 4 times. And eventually you will see polynomials of any degree, with shapes more and more interesting. But the rules you learned in this chapter, they all stay the same. Degree n. At most n zeros. Sum and product from coefficients. Before you go, one small request. If this video helped you understand polynomials, please hit the like button. It tells YouTube to show this video to more students. Share it with a friend who needs it. Group chats, study groups, classroom, wherever it can help someone else. And subscribe to School Revise so you do not miss the next chapter. New videos every week. Every chapter of Class 10 Maths. Plus more grades and subjects on the way. And do not forget the platform itself. schoolrevise.com. Free practice questions, worksheets, doubt forums, and a full Class 10 Maths course. All free, forever. In the next chapter, we move from one polynomial to 2 equations at the same time. Pair of linear equations into variables. You will learn how to solve them 3 different ways. Graphical, substitution, elimination. And we will solve real problems together. Until next time. Practice well. Stay curious. And remember, every great mathematician started exactly where you are right now. See you in Chapter 3.